Hi, this is Miss Litton, and this is my wonderful Period 3 APBio class. Say hi.
Hi.
Okay, so we have some people that just left for choir because they're going to go sing, so we're recording this part of the lecture for them. We hope it went very well. And the question I just asked you is, do you remember what? Independent assortment. Independent assortment occurs during what?
Metaphase.
Be more specific.
One.
Yeah, you could say metaphase 1 or the bigger picture of what? Meiosis. The reason I'm asking you this question is up until now, we have considered the inheritance pattern of a single trait. Okay? That doesn't happen very often, okay? It's multiple traits, how they might interact with each other, so that's why we got to level up a little bit. So in order to have that discussion, I need you to remember meiosis. Now, in meiosis 1, it's all about separating the homologous pairs. In meiosis 2, you're separating the sister chromatids. All right. Independent assortment occurs when? Meiosis 1, what stage? Metaphase 1. And that is saying that when you have a homologous pair like you see right here, each homologous pair can line up independently of the other pairs. Do you agree with that? Okay, can I get your eyes up here? Some of you are not here. Okay, so when I look at this lineup right here, if they line up in this fashion, remember, meiosis 1 is going to separate this guy right here from this one right here. Do you agree with that? Okay, that's going to say. And then in meiosis 2, we're going to separate the blues from each other, and we're going to separate the pinks from each other. Ask your buddy, are you okay with that? Any problems with that?
Yes.
Okay, if they separate in that fashion, and I make gametes, what will those gametes contain? If they are lined up in this way, half the gametes will get a, what kind of B? A little b. On here, let me pull these apart. This would be the genotype. Okay? Do you see why that is the genotype? Because this parent has a big B and a little b. What do you call that when they have a big and a little? Heterozygote. And they have a big E and a little e. Yes? Okay. So if they line up in this way, then I could end up getting, for this particular gamete, they would have what? Which of these B's? The little b and the big E. And the other gamete will have, or all of those gametes will have what? Big B and little e. Just ask your bio buddy if you got that. Okay. Now let's apply the law of independent assortment, which is what we're talking about, right? So they could have lined up this way, or they could have lined up this way. Yeah? See, I just flipped the page. See it? Okay. So if they line up this way, what kind of gametes could we have had? Little b and little e, or big B and big E. So if these were sperm, these are all the possible sperm you could have from this individual's genotype. Are you all right with that? Okay, now you don't have to do a drawing like this in order to figure that out. What you can do is just write the genotype, big B, little b, big E, little e. We know those are on homologous pairs of chromosomes that I put right here, yes? Okay, now, do you remember FOIL from math? What does FOIL stand for? First, outside, inside, last. Do you remember that? No. Did you ever learn that? No. Oh, well, let me show it to you. First, okay? First, you could have had a big B with a big E. First, the first of the pair. Outside, you could have had a what? Big B with a little e. Inside, you could have had a, and last, you could have had little b, little e.
It's like distributing.
Yes, it is exactly. Not even like it. It is it. Okay? So we have 4 different kinds of gametes that we could get. Has our Punnett square got bigger? Yes. How many sides to our Punnett square before? 2. Now how many? 4. All right. So let's take a look at a situation right here. Here is our parental cross, okay? This is a true breeding round and yellow pea plant. So all of its peas are round and all of its peas are yellow. It's a homozygous dominant for that, okay? And we're going to mate it with a homozygous recessive. Every pea is wrinkled and every pea is green. Remember, green is recessive. What are the potential gametes that this individual could make? Then you only got one option here. You can foil it all day long. What's the only thing you're going to get? Big R and a big Y. Those are your only options, right? Because it doesn't matter. Its R-ness is all capital R. Its Y-ness is all capital Y. So that's the only option here. What are your only options here? Little r and little y. So if they unite through fertilization, what is your genotype of this individual? Do you agree with that? Now, tell me, this would be the parental generation. These are the F1s. I want to make some F2s. What are my gametes I would have from this individual? What are the possible gametes?
Big R, big Y, big R,
little y.
Little r, big Y.
And
Little r, little y.
can I have any gametes that are this?
No.
What says I can't? You got a law for that. Law of segregation. Law of segregation, right? Okay, so the law of dominance tells you that this individual will have round and yellow peas. That's what the law of dominance says. The law of segregation, remember we looked at anaphase, right? The law of segregation says I could get a big R with a big Y or a big R with a little y. Law of segregation, I back it up. The law of segregation says I'm going to separate the R's and I'm going to separate the Y's. The law of independent assortment says I can have a big R with a big Y or I can have a big R with a little y. There are your three laws right there. He is round and yellow. Law of segregation says the R's will be separated and the Y's will be separated from each other as long as they're on different chromosomes, right? If they're on the same chromosome, what do we call those genes? They are what? Do you remember? Linked. Yeah, they're linked together. So they will not do independent assortment, okay? Because they are going to travel on the same gene. We're not going to be, well, we'll go with that later. Okay, so do we understand why we have our 4 gametes right here?
Yes.
Okay, so let's try to do that Punnett square without red. Okay, so tell me the gametes one more time so I have them. Big R, big Y, big R, little. Are we okay so far? If this right here, this sperm fertilizes this egg, what is the genotype? Be more specific. Do you agree with that?
Yes.
Phenotypically, what will that look like? Round and yellow. Here we go. Round and yellow. Round and yellow, round and yellow. Okay, what would this one, do this genotype in your head. What would this be? Do the genotype in your head, now tell me the phenotype.
Round and yellow.
What about this one?
Round yellow.
Okay, can I show you a little trick right here too? Okay, if this gamete has a big R and a big Y in it, what can you say about this whole row? They're going to all be round and yellow. Can we see any other row, column that might be like that? First column. Because this one's always going to give round and yellow, yeah? So we can go yep, yep, and yep. You all right? Okay. What about this one? What is it going to be? Round and green, okay? Because any kind of R, big R, is going to be round, and because it has 2 little Y's, it's going to be green. What's this one? Next. What do you think it's going to be? Round and yellow. Okay. Here. Okay. Oh, go back. There we go. What's this one? Wrinkled and yellow. No. Are we okay with that? Wrinkled and yellow. What's this one? Okay, good. Okay, we're good. Okay, what's this one?
Round and green.
Round and green. Yes, I agree with that. What's this one? Round and wrinkled and
Symmetric, diagonal.
what's this one? Wrinkled and green. Okay. What is the most dominant trait there? Round and yellow. Okay. How many round and yellows do we have? 9. Do you agree with that? Okay. So we have 9 of the most dominant. What's the next thing you could do then? Round and green. How many do you have that are round and green? 3. Okay. What's the next one? How many do you have that are wrinkled and yellow? 3. And how many do you have that are wrinkled and green? 1. When you do a dihybrid cross, it's hybrid for the roundness and hybrid for the yellowness. When you do a dihybrid cross, you expect 9 to 3 to 3 to 1 every single time. So you're not going to want to do a big old Punnett square like this. So let's apply what we already learned, the product law. Okay? So same thing, big R, big Y, dihybrid cross. You okay so far? All right. And what you do, if you want to find out how many will be dominant, what's the genotype for dominant? Big R. Big R what? Anything. As long as you have one big R, right? And how about, then what's the other trait? Yellow, right? Would just have to be big Y, anything. Do you agree? Just have to have one big R and one big Y. If we wanted to figure that out, how many show the dominant trait, what we want to do is do individual Punnets. First, just Punnett out your R's. Are we all right with that? Then Punnett out your yellows. It's going to look remarkably the same. Okay, now how many do we have here that are big R anything? 3 out of 4. How many here do we have that are big Y anything? Product law that it would happen at the same time. 3 times 3 is? 4 times 4 is? All right. How about the homozygous recessive, where there's only one way to get recessive, right? What's the trait for that? What's the genotype for that? Little r, little y. What are the odds that we're going to have little r, and little y? What is 1/4 times 1/4? 1/16. Do you see that? So you could do that if I threw on another trait like peas. And I could say, hey, do this one for me. I want to know how many are going to be big R, how many are going to be big Y, and then little p. And you could figure that out just like that, right? What are the odds of big R anything? What? Big R, oh sorry, I said big R anything, you're right. Big R. So that's right here, right? Big R anything, 1/4. Okay. How about big Y, little y? What is it? 1/2. And then the P's are the same as these Y crosses, right? They're all heterozygotes in the one that I gave you. So little p would be 1 times 1 times 1 is 1. 2 times 4 is 8 times 4 is
32.
Product law. Do your individual Punnetts and then multiply them together. Okay, now I want to show you on those P's, here are actually, or that corn, the switch to corn, here is some corn. Now, how many different phenotypes are in this corn? 4. And I labeled them. Do you see that? A, B, C, D. I counted up those corn kernels, and there are 70 corn kernels. What looks to be the dominant trait when you look at that? Yeah, look at right here. See how I have them? What is it? A, purple and smooth, right? So if this is a dihybrid cross because you have 4 different phenotypes showing, what would you expect here? 9/16 times 70, right? 3/16 times 70, 3/16 times 70, and okay, now you would then have to look at those and see what each one was, which I did for you. So I have 3 pictures I need you to do. This picture you do not need to put in your debrief, but I want you to work it out. So take a picture of this. I did observed and expected for you already. But you can do the chi-square test on it to see how you do. Okay? That will be good practice for a chi-square test for you. Okay? Then these 2 I do want in your debriefs. I'm going to give you 2 more pictures. Tell me when you're ready. You ready? Wait, she's taking it? Okay. This I do want in your notebook. Okay, and this one. It looks like the other practice problem you did, but it's not. Okay, got it? So you have all kinds of practice you can do before I see you next time. Have good days. Study the corn. Hope that was helpful. I know I don't mean to do that, but that's such a good way to end it.